everyone, welcome to the real number system that I talked about in my previous lesson. So the real number system is important because it allows us to classify numbers into different groups according to their characteristics. So numbers that have the same characteristics are classified into one group, and that kind of like makes our maths life much more easier because if we know that a certain number belongs to the certain groups of numbers with these certain characteristics, and then we can be able to attach those specific certain characteristics to that number. So the real number system consists of real numbers are denoted with the capital letter R. So real numbers are subdivided into rational numbers and irrational numbers. In my previous video, I gave you a little bit insight on rational and irrational decimals. So I'm not going to get deep a lot into them today. I advise you to go back and watch that video so that you can be more knowledgeable about decimals that are rational and irrational. So rational and irrational numbers are exact opposite of each other. This means that you cannot have rational numbers and this means that you cannot have a number that is rational and again also that number is also irrational. It can only be one of either rational and irrational numbers. And the rational numbers and irrational numbers are in fact the opposites of each are the exact opposites of each other. So that's why I'm going to describe them at the same time in order to reinforce the difference between them. So here we have rational numbers. So rational numbers have three characteristics. That is the first characteristics of rational numbers, that they can be expressed as a fraction, that is in the form of x divided by y. An example of that is 22 over 7, which is the value of pi. So pi is a rational number. And then irrational numbers cannot be expressed in the form of a fraction, such as the square root of 2. This cannot be expressed as a fraction. Then the second characteristic of rational numbers is that rational numbers are recurring, repetitive decimals, such as 0,3333. I had already explained that in my previous video. Whilst irrational numbers are recurring decimals that are non-repetitive, such as this decimal here. It is 0,123456789. And then the third characteristic of rational numbers, which is exclusive to rational numbers only, that means it excludes or it doesn't account for rational numbers, for irrational numbers. It's only for rational numbers. So rational numbers consist of all the non-recurring decimals, such as 0,75, 0,5. I had already explained that in my previous video. Then you see that rational numbers is further divided into integers, whole numbers, and the natural numbers. So you may have heard that. If you have not heard of it, do expect it in an exam situation, that all integers are rational numbers, but not all rational numbers are integers. So this simply means that from a set of rational numbers, you have to take out certain numbers. You have to take out certain types of numbers so that you can be left with integers from a set of rational numbers. Because rational numbers is a mixture of fractions, decimals, and integers. So you have to remove fractions, you have to remove decimals, and you have to remove all other decimals again. so that in a set of rational numbers, you are you are left with only integers. Hope that makes sense. And then we move on to, so integers consist now of ordinary numbers like negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to until infinity, without the fractions and the decimals. And then to get whole numbers from integers, you just simply have to remove all the negative numbers, and then you are left with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to until infinity. You actually remove the negative numbers from integers to get whole numbers. And then to get natural numbers from whole numbers, you just simply remove the 0 here, and then you are left with natural numbers, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to until infinity. They sound like they're counting, and that's why they're sometimes called counting numbers. Now we move on. So if there are real numbers, then that means that there could be also non-real numbers. And that is exactly true, because we have something that we call imaginary numbers, which also call non-real numbers. These are numbers that do not exist. They give us undefined when you press them into the calculator or math error. Examples of such numbers include the square root of negative 4 or anything that is divided by 0. Those are your imaginary numbers. They do not exist. Then we have your complex numbers, which is a combination of two numbers that cannot be further simplified. That is, complex numbers consist of more than one term, such as the example I've given here, which is 1 plus the square root of 3. This is your complex number. Okay, I've come to the end of this video. I hope you learned something from it, and I hope that you stay tuned to this channel for more videos of this nature that are going to strengthen your basics on math so that you become more confident when doing math. And remember, I invite you to subscribe and like and comment so that you stay on this channel and actually benefit from from the upcoming videos. I thank you. Good luck and keep well.